welcome back. This is lesson 4.1 and it's apply triangle sum properties. Our big question here is how do you find the measure of the third angle of a triangle if you know the measure of the other two angles? So that's our big question. We're going to start by filling in this frame, okay? And it's all about the triangle basics. It's about knowing how we name three-sided shapes or triangles based on side length and angle measure. Okay, so this is about knowing how we name three-sided shapes or triangles based on side length and angle measure. So first of all, we have to know interior and exterior angles. So if I have a triangle, these three angles, those ones are all called interior. And we've talked about the word interior, it means inside angles. Okay, so those three angles would all be our interior angles. And then our exterior angle is something we find that if we extend one of the sides, like extend this side right here, this angle on the outside, that would be called an exterior angle. And you could extend your other sides and find more exterior angles. I could extend this side, and this would be an exterior angle as well. So first we're going to classify by side length. Okay, our first classification is by side length. Okay. So with a scalene triangle, we have no equal sides. And an example of a scalene triangle might be something like this. These are all three different lengths, so I'll put a different number of markings on them. Isosceles has two equal sides. An isosceles will look something like this. And those are the same, or you could see one laying on its side, and those two would be the same. An equilateral triangle is all equal sides. So I'll draw an example, and all those sides are going to be the same. Okay? Our next way we classify is classifying by angle measure. Okay, classifying by angle measure. So acute triangles, all the angles are less than 90 degrees. A right triangle, so here's an example of an acute triangle. All my angles are less than 90. A right triangle has one right angle. This would be an example of a right triangle. Put that little box in there to show my right angle. An obtuse triangle has one angle greater than 90 degrees. Okay. This would be an example of an obtuse triangle right there. And an equiangular triangle, equal angular angles. So in this, all my angles are going to be equal. So all angles are congruent. Okay? Our so what here, what's important to understand about this is we need to know how to accurately describe and name angles. That's what's important about this. We need to be able to do that so we can describe and name them to each other. Okay, so our example one, classify triangles by side and by the angles. So it's a shuffleboard on our screen here. It says classify the triangular shape of the shuffleboard according or scoring area in the diagram by its sides and by estimating its angle measures. Okay, so looking at these angles all look less than 90 degrees. Okay, so they don't look the same though, but they all look less than 90 degrees. So since they're all less than 90 degrees, we got to think of what our name is and then look at our sides as well. I thought I had this written in here. So all less than 90 would be acute. And then we have two sides marked here as being equal, and when we have two equal sides, that's called isosceles. So it's an acute isosceles triangle. Our next one, draw an isosceles right triangle and an obtuse scalene triangle. So our isosceles right triangle has a 90-degree angle and it has two equal sides. Okay, so an example of this might be like this. I'm going to draw my right angle there. I'm going to mark that these two sides are the same, and then I'm going to connect it. That would be an example of an isosceles right triangle. An obtuse scalene triangle. Obtuse has one angle that is greater than 90 degrees. And scalene tells us all different side lengths. Okay, so we need one angle greater than 90 and then all different side lengths. So there's an angle greater than 90 and all different side lengths. So that would be a good example of it. Let's look at our example 2, classify a triangle in a coordinate plane. It says classify triangle RST by its sides, then determine if the triangle is a right triangle. So we need to know, first of all, the length of the sides, and then to do this, we're going to use our distance formula. So the distance formula, it's written on your notes, it is not on this PowerPoint, so it's a square root of x2 minus x1 squared plus y2 minus y1 squared. So that's on yours. It's something you should know from chapter 1 though. So to find the length of RT, I'm going to do the square root. I'm going to draw my parentheses and my minus and my squared plus another set of parentheses and squared and minus. R is negative 3, 3. So I'm going to plug negative 3, 3 in here. And T is 3, negative 1. So I'll plug 3, negative 1 in here. And now I just need to simplify this. Negative 3 minus 3 is negative 6 squared. Still got my square root and my plus. 3 minus a negative 1 becomes plus. So that's 4 squared. Okay, so negative 6 squared is 36. 4 squared is 16. 36 plus 16 is 52. So this is the square root of 15, or square root of 52, which is about equal to 7.2. Let's see if I got some blanks on here. Nope, well, maybe I did. So RS, let's again write our square root sign, our parentheses and minus and squared, plus parentheses minus squared. So there's our pattern. R is the point negative 3, 3. So I'm going to plug a negative 3 here and my 3 here. S is the point 5, 2. So I'm going to plug my 5 here and my 2 here. Now let's just simplify that. So I've still got my square root. Negative 3 minus 5 is negative 8. So I've got negative 8 squared plus 3 minus 2 is 1. So here I've got 1 squared. So negative 8 squared is 64 plus 1 squared, well that's just 1. So 64 plus 1 is 65. So I've got the square root of 65, which is about equal to 8.1. ST, again, our distance formula. Square root, parentheses minus squared, parentheses minus here and square that. So let's plug in S. S is the point 5, 2. So we'll plug 5 in here and 2 here. T is the point 3, negative 1. So I'll plug 3 in here and negative 1 in here. And let's just simplify that. So I'll keep my square root. 5 minus 3 is 2. So I've got 2 squared plus 2 minus a negative 1. Well, that becomes addition. So 2 plus 1 is 3. So I've got 3 squared. So 2 squared is 4. 3 squared is 9. So I've got the square root of 13, which is about equal to 3.6. Okay? So looking at this, if we're judging by side length, well, we've got all different side lengths. Since they're all different, this is definitely a scalene triangle. Now we're going to have to look to see if we have any right angles. And this angle kind of looks like a right angle to me. So let's check those two lines. And we know in order to see if we've got right angles, well, that's the same as them being perpendicular, and we know how to tell if lines are perpendicular to each other. So let's find our slopes for both of them. So really we're asking, is RT perpendicular to ST? That's really what we're asking. So let's find the slope of RT. Okay, so the slope of line segment RT, I should put my line segments there. So the slope of line segment RT, here's my fraction bar and my minus signs, here's my slope formula. R is negative 3, 3, so I'll plug negative 3 and 3 in here. T is 3, negative 1, so 3, negative 1. So 3 minus a negative 1, well, that's 4, because it becomes plus positive, over 3, a negative 3 minus 3 is negative 6, and if I reduce that, I get negative 2/3. So let's now find the slope of segment ST. Okay, and again, there's our slope formula, fraction bar and minus signs. S is the 0.52, so I'll plug 5 in and 2 above it. T is the 0.3, negative 1, so 3 goes there, negative 1 goes above it. We reduce across, this becomes addition, so 2 plus 1 is 3 over 5 minus 3 is 2. Now let's compare these. In order for them to be perpendicular, we need to have our slopes be opposite reciprocals. So looking at these two, they have the opposite sign and the fraction is flipped, so they are reciprocals. So yes, this is a 90-degree angle. And since it's a 90-degree angle, well, we know we got a right angle in our triangle since it's a 90-degree angle. So we're going to call it a right triangle. So our classification here, if we think back, we know it's scalene and we know it's right, so we call it a scalene right triangle. Okay. Let's look at our next problem here, our extra example. So you need to go through this. It says triangle JKL has vertices J, negative 2, negative 1, K, 1, 3, and L, 5, 0. Classify it by its side lengths and then determine if it's a right triangle. So pause the video, go through and find all the side lengths to decide what the lengths are. So you can decide what it is based on side lengths. And then also find the slopes. And I'll give you a hint. Find the slopes of JK and KL, because those are the two that will end up looking possibly perpendicular. So pause the video and try that. Okay, welcome back. So if you find the length of JK, you should get the square root of 25, which is 5. If you find the length of segment KL, you get the square root of 25 again, which is 5. And the length of segment JL, you get the square root of 50, which is about 7.1. Looking at that, we've got two equal side lengths. With two equal side lengths, that makes this an isosceles triangle. And then the question, is segment JK perpendicular to segment KL? Well, if you look and find your slopes, the slope of segment JK is negative 4/3. I'm sorry, not negative 4/3, it's positive 4/3. And the slope of segment KL is 3/4. And that one's negative. So those are opposite reciprocals. Since they're opposite reciprocals, then yes, our lines are perpendicular to each other. So we can call this an isosceles right triangle. that problem takes quite a bit of extra work, but that's how you're going to have to do these ones. Let's look at our next problem. Theorem 4.1, it says triangle sum theorem. The sum of the measures of the interior angles of a triangle is 180 degrees. So the measure of angle A plus the measure of angle B plus the measure of angle C has to equal 180. This is a big, big important idea in our class. The inside of a triangle, the inside angles always add up to 180. Our second theorem, theorem 4.2, exterior angle theorem. So the measure of an exterior angle of a triangle is equal to the sum of the measures of the two non-adjacent angles. So the measure of angle 1 equals the measure of angle A plus the measure of angle B. So what we're saying, this angle measure, this equals this angle plus this angle down here. So if you add these two angles together, you get this exterior angle. So let's use those. Example 3, find the angle measure. So use the diagram at the right to find the measure of angle DCB. So in order to do this, our first step is going to be right to write and solve an equation. So we have 3x minus 9 equals 73 plus x. Since this is an exterior angle, it's going to equal the sum of these two interior angles. So we got 73 plus x. If you go ahead and solve this, which I'm going to solve it right over here, 3x minus 9 equals 73 plus x. Well, let's move our like terms together. This will become a negative x over here. This will become a plus 9 over here. So I have 2x equals 73 plus 9 is 82. Divide them both by 2, and x equals 41. Okay, so I solve for x, and in my blank here, I have x equals 41. And I showed my work on the side. The question, though, says find the measure of angle DCB. So we want to know this angle measure. I found the measure of angle x, so I haven't answered the question yet. So step 2 is to substitute 41 in for x and 3x minus 9 to find our angle measure. So let's do that. Okay, so 3 times 41 minus 9, if you put that in your calculator and simplify it, you get 114. So the measure of angle DCB is 114, and that's degrees. Let's look at this next example. It says find the measure of angle 1 in the diagram shown. I suggest you pause the video and try this one on your own. Okay, welcome back. We've got an exterior angle, and we know that exterior angle equals the sum of these two interior angles. So we're going to say 3x plus 16 equals 52 plus 2x. Just added my interior angles and set it equal to the exterior angle. Let's combine our like terms now. Subtract 2x. And I'll subtract 16 over here. Just move my like terms to the same side. So x equals 36. The question, though, says find the measure of angle 1. Well, angle 1 is right here. So this one's a little bit different. So angle 1 is right there. So let's do this way. This angle measure is 2 times 36. So 2 times 36 is going to give me 72 degrees. Okay. These three angles have to add up to 180 degrees. So if I do 180 degrees and I subtract the 52 degrees from one of my angles and the 72 degrees from my other interior angle, I get 56 degrees. Okay? So that's 180 minus really 124, which is 56 degrees. So angle 1 is 56 degrees. Okay, so the corollary to the triangle sum theorem says the acute angles of a right triangle are complementary. This makes sense. If we know this angle is 90 degrees and all three of the angles have to add up to 180, then we know these two If you add them, they have to equal 90 degrees as well. So the measure of angle A plus the measure of angle B equals 90 degrees. Okay, let's look at our example 4 here. So the front face of the wheelchair ramp shown forms a right triangle. The measures of one acute angle in the triangle is 8 times the measure of the other. Find the measure of each acute angle. So we've got a nice picture here, and we've got to think, using that corollary to the triangle sum theorem, well, we know those two angles have to add up to 90 degrees. So using that, we're going to set up our equation. So I have x, that's one of my angles, plus 8x, and that has to equal 90. Again, these two interior angles, when I add them, it has to equal 90 degrees. So I set up my equation. If I solve this for x, well, I've got 9x equals 90. Divide both sides by 9, and x equals 10. So the measures of the acute angles are 10 degrees. This one would be 10 degrees, and then 8 times 10 degrees would be 80 degrees. And if we double check that, 10 plus 80, yep, that's 90, which is what we wanted. Here's our extra example. So pause this and try this one on your own. Okay, welcome back. It says in example 4, what's the measure of the obtuse angle formed between the ramp and the segment extending from the horizontal leg? Okay, so if I extend this side right here, I extended that side, and it says what's the measure of the angle formed between this ramp and this leg extended. Well, we know this one right here is 10 degrees, and because these two are a linear pair, if I just do 180 degrees minus my 10 degrees, then I get 170 degrees. So that angle is 170 degrees. All right, this is the end of our notes for lesson 4.1. So hopefully you got it. If you have any questions, make sure you star them so that we can go back and go over them in class tomorrow. And have a good day.